So, let us see the implementation of stacks. So, the most important thing, you have to implement push and pop operation. Okay. Other operations also we can write the code. So, we are using we are going to implement the array implementation, array logic of using the stacks. So, as usual, the basic header files. Then I have to define the what we say array. We have to define the array. Why we have to do this global? Because I have to use them in all the functions. In push, in pop, I want that particular no. So, I will give yes of some 100. Okay. So, this I am declaring. Another one I will give into top equal to -1. So, I am defining here two things. Again, just for our programming purpose, we will take n as also 100, one variable n is equal to 100, just to maintain this both should be in same, they should be in sync, right. So, then int main right. So, I have to do some operations like this. Push of 10, I should call a function push, then I should call with 20, then again I will do this with 30. I will also write a display function which will display me the let us go and implement the push function. So, void what it will take? It will take one number. See, I am passing a number which I want to insert inside the stack. I am passing a number which I want to insert inside the stack. So, you can write here int some x, anything you can give here, open bracket. So, before inserting, you have to check whether the stack is already full or not. How will you know? We know that using top. So, if top is greater than or equal to n minus 1, if top is greater than or equal to n minus 1 means top, what is the top? Top is a pointer which will be pointing to the element, the topmost element. So, if it is at 99 index, if it is at 99 index, it means the stack is already full, that array is already full. So, you can say something like this, you can say the stack overflow, okay, means the elements are already inserted in that. Else what you have to do, simple step, in else you can write that's s of plus plus top, okay, s of plus plus top equal to that variable x. That is it, with this element is inserted into the stack. Or you want to put some message, you want to write it very clearly and more interactive, you can do it like this by writing cout element inserted into stack. Okay. So, I have just implemented push, this is that simple logic. You are checking whether the top is greater than n minus 1, then you are saying stack overflow. Otherwise, you are just incrementing the top, and in that index you are putting the new value x, which I am passing from here. Okay. So, this is about the this yes push operation. Now, let me write display and check whether this is inserting elements or not. So, void display, sorry, what I have to do here in this display function, I have to check if the stack is empty or not, that I also have to verify. Okay. I have to verify whether the stack is empty or not. Again, these are just to make the program more interactive and meaningful. So, if how do I know that whether stack is empty or not? If top value is less than 0, if top value is less than 0, I can say cout stack is empty, some message, and L. Otherwise what I have to do, right? I will for loop, I can use some for loop for some int j equal to 0, j is less than how long should I print? I should print only till the pointer top, I should print only till the pointer top. So, wherever top is there, I have to write it equal, because top is equal to your index actually, top is equal to your index j plus plus. Top is a pointer which is storing the index of the element, the last element, the latest entered element index it is managing. So, I can write cout of s of j, it is yes, right? Yeah, name of the array is yes, s of j and n del, or you can give something like this. Okay. So, this will do, or maybe I will write one more message here to make it more meaningful. The elements of the stack are, okay, like this. So, this will display. Now, let us check whether this is working fine or not, whether it inserts elements into the stack or not. Okay. See, element inserted into the stack, the elements of the stack are 10, 20, 30. Why? I wrote here, right, I am pushing 10, then 20 and then 30. So, it has inserted elements 10, 20, 30 into the stack. Okay. Now, let us implement the, again this is unnecessarily repeating for no always. So, we do not need this. Check it here. See, the elements of the stack are 10, 20, 30. Now, let us do pop operation and check what is the operation. I will write pop, then I will write cout elements after pop operation are. Okay. I should know the difference, right? That is why again I will display the elements. So, let us write code for pop, same like this, same like push operation. Pop will not take anything, because pop job is to delete the topmost element, that is it, I am not inserting anything. So, before deleting, again you have to check if the stack is empty, because you cannot delete when the stack is empty. How do I know the stack is empty? If the top value is less than 0, then you can say cout stack under flow, right, stack under flow, else this any additional bracket here, yeah, some additional bracket has come. Else what I have to do, if you do not want to do that pop up, you want to delete the topmost element. If it is not under flow, it means there exists some elements, then you can write cout the deleted element is, okay, we can write here s of top and L. Then what you have to do? You have to write top minus reduce your top. Okay. So, this is your pop operation. It will not take any parameters, it will just check if the stack is empty. If not, it will say the deleted element is whatever is the top, that will be deleted, and it will do top minus. After that, again I am displaying here, see, elements after pop operation are, I am again calling the display function. Okay. Let us see whether it is deleting 30 or not, because 30 is the topmost element. Let me execute this. See, the elements of the stack are 10, 20, 30, the deleted element is 30. Okay. Elements after pop operation are 10, 20. Okay. Right. So, here where am I printing it? Yeah, instead of this I will put end L, that is more better. See now, the elements of the stack are 10, 20, 30, the deleted element is 30, elements after pop operation are 10 and 20, 30 has gone, because 30 is the topmost element, right. So, this is the simple implementation of what we say stack operation using arrays push and pop. Okay. You want to use other functions like is it empty, underflow, is stack empty, or is stack full. You are checking the logic here already, no? Is stack full, you can say yes or no. Is stack empty, you can say yes or no, right. You can implement that. Already we are checking it here. Stack empty or is stack full, did we write anywhere? Yeah, stack overflow, that stack is, this is the logic for that. Okay. In some textbooks they will have this one more function called peek. Okay. There is one more function, again this is an auxiliary operation on stack, that is peek. What is this peek? Peek means it will give the topmost element, it will return the topmost element, whatever is the topmost element that will be returned. So, what it will do? Void peek, if I do, okay, it will simply cout the peek element is, you can write there yes of top. Whatever is the top, that will be displayed. That's it. In some textbooks, you may see this kind of things, peak. So simply display. But again, before this, you have to make a check if the stack is empty or not. That again, this is the common thing which you can copy paste and do it. So let's see what it tells. See, the elements of the stack are 10, 20, 30. There is one pop operation that is deleting 30. The elements after pop operation are 10 and 20, and the peak element is 20, and the peak element is 20. That means it is the topmost element in the stack. Okay. So this is the array implementation of no stacks.